Lastly, another example, this one's using a fifth root. So our goal is to look at each of the items or each of the terms within the base or within the radicand and refactor them into something that factors with a perfect fifth root. So 64, one of its factors, that's a perfect fifth, is a 32. X to the cubed, that has no perfect fifths in it, so that just remains x to the cubed. Y to the seventh, that can factor down into y to the fifth times y squared. Z to the 29th, its greatest factor, that's a factor of a fifth root, will be z to the 25th times z to the fourth. Now again, we have to keep in mind how we multiply bases and exponents to help us understand how we can redistribute or find the factors of these various ones. From here, let's just look at each individual term and see which one is a perfect fifth root. The fifth root of 32, that's a 2. So I can pop him on out. The fifth root of 5, I cannot. So he remains in the fifth root. The fifth root of x cubed is the fifth root of x cubed. There's no perfect fifths in that. The fifth root of y to the fifth is y, because y times itself 5 times is y to the fifth. The fifth root of y squared, the fifth root of y to the 25th, what times itself, or z, those are z's, folks. Z to the 25th, what times itself 5 times makes z to the 25th? 25 divided by 5 gives me z to the 5th. And then I have the fifth root of z to the 4th. That does not escape. So my final solution then is 2 times y, z to the 5th, times the fifth root of 5x cubed, y squared, z to the 4th. Now we are in completely simplified form.